Friends, my name is Bhushan Kulte. Welcome you all in our channel named as Last Minute Passing. As we know that friends, on 16 there is examination of refrigeration and air conditioning for 2008 and 2012 batch. So basically we know that on the our strategy we had given that question number 5, which is basically asked from unit number 3 for nearly 10 marks. So we have just taken that numerical of the previous examination and we are solving that. The question is a multi-evaporator refrigeration system with an individual compressor and individual expansion modes using R22 as a refrigerant as shown in the figure. Neglecting the undercooling of liquid and superheating of vapor refrigerant. Find power required to run the system and COP. Here they had given that we are using multi-evaporator system with individual compressor and individual expansion mode, and the refrigerant which we are using is R22, means the values of enthalpies means H1 H2 we are calculating is from the chart of pH of R22 refrigerant, and then clearly mentioned that neglecting the undercooling of liquid and superheating of vapor. Means undercooling means at the outlet of condenser, means 0.6 is basically on saturated liquid line, and superheating of vapor means 0.1 and 0.3 means at the inlet of compressor they are basically on the saturated vapor line. If they are not mentioning, we have to consider this. If they are clearly mentioned that there is no need, we have to neglect that, so we are neglecting that. So first of all, we will basically for solving this type of question, there is a particular sequence. They have provided the particular sequence. Please go through it. Means in the first step, we will calculate all the enthalpies like H1, H2, H3, H4. So as we know that we are using R22 as a refrigerant. So we will plot this pH graph on our R22 pH chart. This is as we know that in examination there is a provision of R22 pH chart, but here we had taken, and with the diagram which we plot here is completely means we will directly plot that on the pH chart, and the values of H1, H2, H3 and H4 we will directly get from this our R22 pH chart. After the calculation of this H1, H2, H3, all these enthalpies, there is a second step is that calculating the mass flow rate. As we know that in the compressor 1 and compressor 2 means we are using different compressors, so there is a different mass flow rate. So for calculating that, there is a formula that is RE1 into 211 divided by H1 minus H8. Means RE1 is what? It is refrigerating effect of first evaporator. We are multiplying it with respect to 211, means we are converting it that into ton of refrigeration into kilojoule per minute, and divided by its what can I say, H1 minus H8, means it is nothing but a refrigerating effect of first evaporator, and in the second we are using H3 minus H7, means we are calculating the refrigerating effect of second evaporator. From that, by putting the values, we will get mass flow rate of 1 m1 dot and mass flow rate of 2 m2 dot. Then the third step is our basic that they had mentioned that power required to run the system. As we know that in the system we are considering the two compressor, so there is a need of using PC1 and PC2. Means there is a need of considering the two power required. If there are three compressor, we will go through it three. So basically for calculating this PC1 and PC2, we know that what from point 1 to 2 and 3 to 4 we are using compressor. So PC1 for compressor 1 there is H1 to H2, H1 to H2. So the formula is used is m1 dot upon 60 into H2 minus H1, and the compressor 2 is run between H3 to H4. So there is a formula for calculating the power is m2 dot upon 60 into H4 minus H3. By putting the values of m1 dot H2 H1 and m2 dot H4 and H3, we will get a power which is basically 28.78 kilojoule per second or kilowatt. Then next they have mentioned that calculate the overall COP or coefficient of performance of the system. So COP is basically nothing but it is a ratio of refrigerating effect upon power supplied. Refrigerating effect, as there is we are using two evaporators, So RE1 plus RE2. Basically they had given this refrigerating effect value in the term of ton of refrigeration, which is basically 10 and 20 ton of refrigerant. We have to convert that into kilowatt. So we are multiplying it by 3.517 divided by the power which we recently calculated from power required of the system, that is 28.78. So from that we will get the coefficient of performance of the system 3.67. This is the basic procedure of calculating any type of problem. If we get any type of problem, just they will change the values, but the procedure is same. Go through it, you will definitely get 10 marks. Thank you.